talk about logarithms. For anything we can do to a number, we have to have a way to undo it. So if I add, I could undo adding by subtracting. If I multiply, I could undo that by dividing. If I square, I could take a square root of it. So we always need a way to undo what's being done to a number. So if 5 is being raised to the x, and that's equal to 7, and I want to know what power that needs to be, we need a way to undo that raising to a power. We cannot do this with a root. If it was 5 squared, we could take a square root. But I can't take an xth root, because if I take an xth root, when we take a root, a square root, we're saying what number times itself twice. So there's already a question in there. The question is, what number? If I take a cube root, what number times itself 3 times? If I take an xth root, I would be saying, what number times itself how many times? There's 2 questions in there, and we can't answer 2 questions at once. So an xth root doesn't work. So the way we undo an exponent is with a logarithm. So a logarithm, which we abbreviate log, is a way to undo exponentials. Our notation is that we say log, and then there will be a little subscript, a small number dropped kind of half a line, and that's called our base. We read it as by saying log base b. So we announce that what we're saying is the base of y equals x. Okay, log base b of y equals x. And that is a way to undo an exponential. So we have a way of moving back and forth between them. When we do that, the base stays the same. So the base will still be b, but the other stuff is going to flip-flop sides of the equation. So when written as a log, y was on the left-hand side, but when written as a power, y is on the right-hand side, and vice versa for x. Now, why might that be that they switch sides? Way back in chapter 7, we talked about how to take inverses. We did it mostly with linears. What was our first step to taking an inverse of an equation? Switch x and y. Good job. It was a long time ago. This was like before Christmas stuff. It was on our first semester exam. First step to taking an inverse was to switch the x and the y. So logs and exponentials are inverses of each other, so they have this switching that's going to happen. So our first type of question is just to rewrite or practice how to move back and forth between them. So we're given a log statement. We want to rewrite this as an exponent statement. The base will stay the same. So the base of this log is that little subscripted number 2. Then the other stuff is going to flip-flop sides. So I'm going to have 2 to the power of 5 equals 32, which is a true statement. 2 to the 5th is 32. So when all of the numbers are given, then we can kind of check our work by making sure that it turns into a true statement. So the base stays the same, and the other values flip-flop sides. So in this one, what is the base? 5. And the other stuff will flip-flop sides. So 5 to the 0 equals 1, which is a true statement because anything to the 0 power is going to be equal to 1. What is the base in this one? 10 to the power of 1 equals 10, which is a true statement. Okay. So when we rewrite, the base will remain the same, the other stuff swaps. Questions? The next one has us doing it backwards. We're given an exponential and we want to write it as a log. So we're going to write log. What is our base going to be? 10. The base stays the same, and the other stuff flip-flops. So log base 10 of 0.1 equals -1. Now we can't really verify this because we don't know how to evaluate logs yet, so we just need to think of it as being the backwards process of the previous problems.
Can you go back to the ones where it's doing it into exponential form?
Sure. So the base would stay the same, which is 10. To the power of the other stuff is going to swap sides.
Okay.
All right, so in this last one then, we write log, what's our base? 1/2. And make sure you're writing that as a subscript. So it's kind of like putting a footnote into your writing. It's a smaller number that's like half a line down. It's not all on the same level. So that's log base 1/2. It should be subscripted down of 2 equals -1.
What's the thing between the log and the 2?
That's our base of 1/2.
Okay.
So it's our subscript of 1/2. Just like a power is like a superscript, a log is a subscript. Okay. Questions? There are 2 logs that we can evaluate easily by looking at them, or 2 types of logs, I should say. The first one is anytime we have a 1 inside of the log, no matter what the base is, it is going to be equal to 0. So if you are asked to evaluate the log base 47 of 1, it has to be 0. Because the question that a log is answering is to what power? So what this means is 47 to what power equals 1. That's the question a log is asking. So 47 to what power equals 1? Well, anything to the 0 power equals 1. So anytime we have a 1 inside of our log, no matter what the base is, we are going to get 0. And one other special case is if the base and the thing inside of the log are the same, it will equal 1. So log base 93 of 93. Well, the question a log is answering is the base 93 to what power would equal this number? So 93 to what power equals 93? 93 to the first power equals 93. So whenever we're taking the log of the number 1, regardless of the base, we will get 0. And whenever we are taking a log where the base and the number inside of the log match, we will get 1. To evaluate other logs, we want to think about asking this question of base to what power would give us that number. So this is saying 3 to what power equals 81. Or we can think about rewriting. So I can say this is equal to x, where x is my answer. And if we rewrite it, as we did in the first group of questions, what would this turn into? 3 to the x equals 81. So 3 to what power equals 81? And then we need to do some guess and check. So you can kind of grab a calculator and say 3 to this, 3 to this, 3 to this, trying to get 81. And 3 to what power is 81? 3 to the 4th power. 3 times 3 times 3 times 3 is 81.
There's no way to do it without guess and check.
Not at this point. At this point, it's going to be guess and check for us. As we proceed into lesson 6 after spring break, then we'll learn ways to do it precisely without guess and check. And then our answers won't necessarily be pretty, but for now they'll be nice numbers. So for this one, we could say it's equal to x, where x is our answer, and rewrite it. What will the statement become when I rewrite it? 5 to the x equals 0.04, because a log is asking the question of base to what power equals that number. So 5 to the what equals 0.04. Now we can't evaluate these on our calculator. We can use our calculator for the guess and check, but we can't actually do the evaluation. So as much as students don't like them, it is often easier to see patterns in fractions than it is in decimals. So we want to turn this 0.04 into a fraction. This is 4 over what? 100, because it's in the hundredths place, back when you learned those decimal places. So that means that it's 1 over 25. Well, if it was 5 to the x equals 25, that would be a little bit easier of a question. If it was 5 to the x equals 25, what would our answer be? 2. But it's flipped. So it's a negative 2. Why is it a negative 2? Because negatives do reciprocals. A negative power is a reciprocal. 5 to the negative 2, a negative exponent, creates a reciprocal, which makes that flipping, and then 5 squared would be 25. So when one side is a fraction and the other side is not, your answer will have to be a negative number, because that comes from the flipping. So to begin this one, how would I rewrite? One half to the x equals 8. 1/2 to what power is 8? Well, one side is a fraction and one side is not. So what does that mean about my answer? It'll be negative. And then I can ignore the fact that it's a fraction and just think about it as being 2. So 2 to what power would be 8? How many 2's do I multiply to get 8? 3 of them. 2 times 2 times 2. So one side's a fraction, one side is not. Means our answer will be negative. And then you can just evaluate the single number. So 2 to what power is 8? 2 times 2 times 2 is 8. So 2 to the third. Questions? One more of this type. So we'll start by rewriting 9 to the x equals 3. Well, we don't have any fractions, so that means that our answer is not going to be a negative number. But it gets smaller, which is kind of strange because when I think about powers, I tend to think about bigger. So like 9 squared is 81. Stuff's starting to get bigger. So how is 9 related to 3? So how do I get from 9 to 3? The square root. The square root of 9 is 3. Well, how do I write a square root as an exponent? A 1/2. Back in chapter 7, we learned that fraction exponents are the same thing as roots. That 9 to a 1/2 power is the same thing as the square root of 9. So when our value is getting smaller by doing an exponent, not fractions, not where one side is a fraction and one side is not, but where the value is getting smaller by doing the power, that means what we really must have done is some sort of a root. So was it a square root or was it a cube root? What kind of root was it? And roots are fraction exponents. Questions? There are 2 types of logs that your calculator can evaluate. That is the natural log and the common log. The common log is the log with base of 10. The reason why we call it the common log is because it matches what our number system is. Our number system is set up in powers of tens. Back in elementary school when you learned your decimal places, we have the tenths and the hundredths and the thousandths. So it's set up by tens. Our common log is our base of 10. If you see log written and there's no base there, that means the base is 10. Just like if you see a root symbol and it doesn't tell you what kind of a root it is, we assume it's the square root. If you see a log and it doesn't tell you what kind of a log it is, it's a base of 10. It's the common log. Your calculator can evaluate a common log. The other type of log your calculator can evaluate is a natural log. It is called a natural log because it occurs a lot in nature. So like on Friday, when we talked about carbon dating and exponential decay, using the natural log becomes an important part to solving those questions. The natural log has a base of e. We learned last week that e is that irrational number, kind of like pi, the decimal that goes on forever and ever and ever. So the base of the natural log is e. This says ln. It's a lowercase ln. It's not an I. Students always want to write capital I-N. It's an L for the word log. So it's like log natural. It's backwards because in a lot of languages, they actually do their adjectives backwards, like in Spanish and Latin and stuff like that. We say our noun first and then the modifier, so it's log natural. Instead of English, we say natural log. But ln is our abbreviation for the natural log, and that has a base of e. Your calculator can evaluate that one as well. So the next question asks us to evaluate it on our calculator. To do that, your log button is right next to the 7. I'm going to say on log of, the question said 5, and that's our common log. Now remember what the calculator is doing here. A lot of times when students start using their calculator, they forget really what a log is, and it just becomes this like magical button on the calculator. This is answering the question of, well, first, what's the base? 10. So this is answering the question of 10 to what power equals that number. So 10 to what power is 5? Is 10, but 10 to the 1/2 would be the square root of 10, which is not 5. So this is 10 to what power is 5? 10 to about the 0.7 would be equal to 5. That's the question that a log is answering, because it's giving us a power as our answer.
So you don't have to include the 10.
No, if there's no 10 written, then it's assumed that the base is 10, if there's no base at all. The next question asks you to evaluate the ln or natural log. That button is right next to the 4. The natural log of 0.1 is our last example, which is about negative 2.3. So again, the question this is answering, what's the base of ln? E. So this is answering the question of e to what power is 0.1? E to about the negative 2.3 should be 0.1. So that's the question that the calculator is answering for us. Your homework is from section 4. And that is due tomorrow.